With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? A conducting ring of radius 1 meter is placed in a magnetic field B of 0.01 Tesla, which is oscillating with a frequency of 100 Hertz, okay, with its plane at right angle to the B. We need to find the value of the induced electric field, okay. So induced electric field, we need to find it. So first of all, what we need to do, we should find the value of the induced EMF. Induced EMF is equals to minus d phi over dt, okay. And if we take the this mod of this value, if we just take the magnitude, because we have been just asked with the magnitude of electric field, so first we find the magnitude of induced EMF. So this would turn out to be d phi over dt. Now how is induced EMF related with the electric field? So we know that integration of this closed integral E dot dl, this would be equals to the induced EMF E, okay. This is basically minus d phi by dt, and it is equals to E, okay. Now if we get to know the value of this E, then we can find the value of the capital E, where capital is the electric field, small is the induced this EMF. Now how to get the value of this? Now induced EMF could be get by the change of the flux. So how is the flux given? Phi is basically B dot A, okay. B dot A is the flux. Now since magnetic field is perpendicular to the plane, it is at right angle, okay. Magnetic field is at right angle. We write this as B into A into cos of theta, okay. Magnetic field is perpendicular to the area, and area vector is what? For example, if we draw the situation, if we represent this a coil, so magnetic field is in this direction. This is the direction of the magnetic field. And what is the direction of the area vector? It is also perpendicular to its plane. This is the direction of the area vector, okay. That means angle would be equals to 0. So we can say that our phi would be equals to B into A, okay. This would be the maximum value of the flux, okay. But since our magnetic field is oscillating with a frequency of 100 Hertz, that means magnetic field would be changing. So initially at the start, magnetic field value would be equals to what? At the start it would be equals to 0. Then it would increase, and after some time it would reach its maximum value B, and after some time it would be falling, okay. This is the basically behavior of the magnetic field. So it is just a sinusoidal variation of the magnetic field. So we just represent the magnetic field like this. So initially the magnetic field would be 0, after that it would be maximum, and then it would turn out to be 0, then negative maximum, and then 0. So this would be, and the frequency is given as to be what? 100 Hertz. That means from 0 to a maximum magnetic field, let's call it to be B, what is the value of the time for this? So total time would be equals to the time period. So this time would be equals to T by 4. That means our flux, which was linked with the initial magnetic field, initial flux, initial magnetic field is 0, so 0 into A, this would turn out to be 0. Now the final flux, or we can just call it as the mean value, it would be equals to magnetic field value is B multiplied by the area of would be that of the circle, so pi r square. So what would be the change in the value of the d phi over dt? D phi over dt, it would be equals to final flux minus the initial flux divided by the time. What is the time from here to here? The time is T by 4. This value would be equals to the induced EMF, magnitude of induced EMF. Now we put the value, so it would be, so if we put this, so we can say that B pi r square minus 0 divided by T by 4. Or we can say that if we put the value this 4 to be in the numerator, then 4 times B pi r square divided by time period, okay. Now what would be the value of the time period? Time period is 1 by frequency. So if we put frequency is 100, so the time period would be 1 by 100. So we can say that our mod of E would be equals to 4 into, we put the value of B value is given as to be 0.01. We put the value of B as 0.01 pi into radius value is 1, so 1 square divided by time period value would be equals to 1 by frequency, 1 by 100. So this would turn out to be 4 pi volts, okay. Now if we put in our first equation this value, so E dot dl, so we can, electric field would be constant, so we can take it out of the integral, so it would be E times dl, this is equals to small e, which is equals to 4 pi. Now for a ring, what is the value of dl? If we integrate the line element here, if we integrate, it would be just the circumference. So we can say that E into 2 pi R, this would be equals to 4 pi. So from this expression, we can say that our electric field would turn out to be 4 pi divided by 2 pi R. R value is 1, so it would be just equals to 2 volts per meter. This would be the value of the electric field. So which option would be the correct option? Correct option would be the B option. It is 2 volts per meter. We just check. Yes, the correct option is the B option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.